with this slide to start. So this is the Chapter 13 Mastery. If you need the Progressing to Mastery, it is right here, where they always live. So there's your, and it is 8 questions, like I said. It is just surface area volume, straight up 8 questions. Please don't bum rush it now. Wait and grab one later.
Okay.
Ella, question. Yeah, like write a little note about that or whatever. And really, the Progressing to Mastery is just some added practice. So it would be of benefit to you to do it. So it's not like don't think about it of do I have to or not. It's should I. And if I could benefit from a little bit more practice, then you should do it. Like, you know what I mean? So it's only 8 questions. They're not too tough. They're actually, a few of them are definitely easier than the original Mastery. A couple are the same shapes, just maybe where I asked you to find volume, you're finding surface area now.
Good afternoon, Lainey Reynolds. Please come to the office. Lainey Reynolds to the office, please. Thank you.
So where have we been? Because we're 6 minutes into class. Where have we been? Okay, it needs to be faster. You're missing too much academic time. Okay, otherwise we're going to have like bathroom buddies or something really dumb to make sure that you're not screwing off. Because I feel like going to the bathroom is starting to just become an excuse to not be in class. And like Mrs. Cullinan just said, it's your education. Sure, your test scores are attached to me, but I don't really care that much. Like, I care that you do well, but if you don't care, I can't make you care. So, we're going to review this mastery. And I do not want to move on from a question until everyone is totally good that they understand what that question covers. So, we talked about question 1 yesterday. But are we 100% totally good? We understand how to find the surface area of a prism such as this. We talked about 2 different methods. We can use the formula if we want, or we can just match up faces. Front matches back, top matches bottom, and left matches right. Any questions remain from number 1? So,
what's the formula again?
So if you're doing Prism, and this is specific for prisms, but the surface area formula is that we have 2 of the base, because the bottom and the top are both bases. This is really off-orient. I need it oriented again. But then plus the lateral area. And that lateral area, this is the problem, is there's a formula inside the formula, is the perimeter of the shape. Well, here, we don't have to use the cursive L, we can just use the height. But either way, it's the perimeter of the shape times the distance between the bases. So this is really distance between bases. You don't have to call it height, but that's often what we represent it as.
Good afternoon. Reagan Jolly, please come to the office. Reagan Jolly to the office, please. Thank you.
So while I orient really quick, check out number 2 or even beyond those. See what questions or why, like I gave feedback, I notated, I circled some things, put question marks where things didn't make sense. Look at what is giving you issues so when we get to those questions, we can identify those mistakes and fix them so we don't make them again. So, here, we started talking about this yesterday, right? Like, I think we just had very mild conversation and we had to get out of class. So we need to calculate the surface area, but that's not the end of the problem. So Brady, what's up, man?
Oh. So you talked to who said that?
Did you raise your hand for like a question or an answer or what?
An answer, but I lost.
So to get to price, we have to first find surface area because we are working under a problem of 3 cents per square inch. I would underline or highlight that because that is very important. And even more importantly is the square inch tells me I need area. Because it's talking about square inch, I must need area. And if we're covering the whole thing, then do the area of the whole thing. So I can start with really whatever we want. Let's do bottom first. Just how this is sitting, or like, and some people treated the bottom as the big rectangle. That's fine. It doesn't matter. What you have to make sure is that you use each edge length twice. So if I do bottom and then right and then front. So this is bottom and that's front, because then front will match back. So my bottom here that I kind of shaded in on red, what dimensions, Acacia, does that bottom face use? 3 and 7. So 3 times 7, that'll give me 21. Bless you. My right face, Carolyn, what would my right face use? What dimensions? Ooh, the 3 and... You're right, this is 3. Yeah, this would be 9. So that's 27. And then my back or my front will share the same dimensions. So I look at this face now on the back, which would be the same as the front. Ellie? 7 times 9. I've used each edge length twice. So 63. But I've only counted 3 of my faces. So then what do I do with these values? Katie? You multiply each of them by 2 because the bottom matches the top and together they're 42. Together the right and left are 54 and together the front and back are 126. We then sum it all, and this is where the trap door is. Olivia, why is there a trap door here? Okay. But do you know the answer? Yeah, well, so Brady, when you raised your hand earlier, you were raising your hand because you had the answer. What's the answer to the final answer here? What's our price become? But that's not our area. Our area was 222 when I add these up. Because, how? How did I get from one to the next? Ellie? This is amount, sorry, that's in the way. This is amount of square inches. So we multiply by the price per square inch, and that's how we get the $6.66. Questions that remain on this? Give out your mastery for me, bud. The one we handed out yesterday and started working on. Chapter 13. So, and then the progression, the masteries are up here. Okay.
Can I get one right now?
No, wait till the end of class. I told everyone else to wait. Any last questions on this one? How we found the surface area, how we got to price. Because I see some faces that still don't look that confident. Yeah, what? So we reason through this one face at a time. So if I use all like highlighting to do this, that might be easier. So this, let's just clear the whole thing. This face. Forget about everything else. Forget about the dotted lines where you can look through. We're looking at that big rectangular face closest to us. Okay? We know the dimensions, but they're not labeled everywhere. So these dimensions, this 3 is also a 3 on that edge, is a 3 on that edge, and is a 3 on that edge. That 7 is also a 7 here, a 7 there, a 7 there. And the 9 is also a 9 here, a 9 there, and a 9 there. So I can help myself out if I label these other edges. Because if this edge is 9, the other 3 edges that are parallel will also be 9. So then I start to compute area. That front face uses this 7 and that 9 to make up that rectangle. So that front face becomes 7 times 9, or 63. Then we keep doing that, and the front matches the back. So instead of computing another face for the back, we know it's identical, and that's why we did the times 2 on each of them, because it matches the back. Now what else you could say is once you figure out the front, you could say the back is also 63. If you don't like the times 2 method, just write both of them out that they're both 63. Then we could move on and say, okay, this bottom face right here, what dimensions does it use? Well, we labeled that as 3, and then we labeled the other edge of it as 7. So that gives me 21, and we know if the bottom's that size, so is the top. So if you don't like the multiplication by 2, just list it all out. Then we do that again for my left. So this face uses 3 times 9, gives me 27, and that also tells me that the right will be 27. So that's another way we can approach this instead of doubling everything, is just look at, okay, these and these and these all together make the total surface area, because those are my 6 faces. Front, back, left, right, top, bottom. Any remaining questions?
Are we just going through questions that people think they want to know about?
I'm probably going to hit each of them because based on my grading, it seemed like at least some people, like, you know, not everybody missed the same questions. It was kind of a variety. Surface area of a cube, and on your progression to mastery, I make this really easy because in that problem, is my cube around here? Yellow, no, not yellow. In this problem, you have this. But if it was your cube and if it was tangible, Saul?
Oh, yeah. I was going to ask. Sorry.
Okay, is it related to this problem?
Related to the actual test.
Okay, what's your question?
Oh, so the question is, do we have to do the, progressing math?
So we talked about that
Since-
yesterday.
No, since we're, like, doing all of the tests. Can we just turn this in?
It depends on how you did the first time through. If you did very well the first time through and you got the whole thing done and you only made a couple errors, you're giving yourself your grade. But you're turning that back in. So if you give yourself mastery and you hadn't answered half the test, I disagree with that. And we're going to have a conversation about what your understanding of mastery is. So talk to me at extensions or whatever if you're confused on how that works, but most of us probably should do the progression to mastery. It's only 8 questions. It's just some more practice to make us solid. So this cube is this. But if I'm talking about area, we can just look at the net. So on the progression to mastery, I literally show you this. And I say, okay, if these edges are whatever length, and it's different on the progression to mastery, but if these edges are all 3s, this square, forget about everything else. This one square, what's its dimensions? Josh?
Its dimensions are 8 by 8 by 8.
On here?
Wait, no, 3 by 3 by 3, sorry.
The square. One square,
Oh,
not the
one
cube.
square, 6. The dimension?
The dimensions of one square in this cube.
It is 9. Wait, 18.
You're overthinking. The dimensions. How long is... Brady, stop. How long is this edge?
That edge would be 3.
How long is this edge?
That's 3.
So then the 9 you gave me was telling me the
One space.
what of the face?
The
The face is...
front.
The face is area.
Okay.
So one face is going to be 3 times 3. So that gives me that one of the areas is 9. However, how many do I have? 6. So all we need to do with that is say, well, my surface area will be 6 times that 9, and comes out to be 54 feet squared because it's area. Any remaining questions on that? That's it. Yeah, that's all you have to do for 3. Now, there's other ways that you can solve it. You can use the formula. You can reason through it other ways. But that's the easiest because, you know, every face is identical. All right, our creepy room. No doors, no windows. However, most of you, I would not trust the paint. Here's why. A lot of you, I come back and I step into the room and I'm immediately standing in wet paint. You don't paint the floor. And you also use different paint for the ceiling. You're painting 4 walls. A lot of you painted the entire room. Model this. Easiest way to understand is model. We've got a room that's 10 by 10. So I think about a room, it's 10 feet by 10 feet. And I'm thinking about it at dimension or in perspective, so I can look at how tall it is. Brady, how tall is the wall? How tall is the room, really? Question 4. 9 feet. So we don't have to overthink this. The room is square. The square room. Which tells me what about the room, what about the walls, or what about the edges? What do we know about the room since it's square? Caleb? Every wall is the same. This is why I didn't want you to think about doors or windows. That would make the walls different from each other. If every wall is the same, how do I figure out the area of one of the walls? Derek, can you help me out? If I know...
Multiply 9 by 10.
Multiply, what do you get then?
90.
So if the area of one of the walls is 90 feet squared, which that's not a great way to notate that. You should really write out FT. How do I figure out the total area of the room? You want to keep going there?
Multiply the area of one wall by 4.
Yeah, we take that 90 and multiply it by 4, and that gives us 360 feet squared. Then, Ryan, we're told that every can of paint can cover 200 square feet. How can we reason through how many cans we need? Yeah, if that covers 200 feet squared, we cannot order partial cans. So therefore, we need, instead of 1.8, that rounds up.
Good afternoon. Colin Williams, please come to the office. Colin Williams to the office, please. Thank
You
you.
would keep it for touch-up paint. So you always, and this is off the topic of math, you always want to buy too much paint. Because your little brother is going to come in your room, smash the wall or whatever, and you're going to need to have some touch-up paint. Ryan?
I read this
No,
right here.
you're good. I was just asking for help with the problem.
Oh, well,
Yeah. I was just calling on people at random. Yeah. So does anyone now see that you did the floor and ceiling also accidentally?
Yeah.
If you ended up with an area of 560, you also did the floor and the ceiling. So there's your mistake. Careful reading. We're only painting 4 walls. Sebastian, question? So, hold up. Sebastian asked a great question. If every gallon of paint covers 200 square feet, he said, how much paint do we need to cover the ceiling? Well, how big would the ceiling be? What area? 10 by 10. So that's what? What area? 100. So if each can covers 200, we need half a can for the ceiling. You don't want to paint the floor. Someone's going to be very upset.
But then if you walk in the room, then the paint will drip on you.
Okay, simmer down. This one was a big issue for a lot of us. Especially if you're using graph paper, and if you need another sheet of paper, now would be a good time to grab a sheet of graph paper. I would draw this out using the values that we know, except instead of using 3 by 5, when you're on graph paper, I would go 6 boxes by 10 boxes. And then label it 3 feet by 5 feet. Now you can do 3 by 5. You're just going to get kind of a small rectangle. So 3 feet by 5 feet. And then, and I give you a big hint here, our tiles are 4 inches by 4 inches, which a lot of you, when you came up and asked me for some help, I said, well, think about it. One tile is 4 inches by 4 inches. And if I ask you, well, how many tiles will it take to get across the room or get down the room, most of you then figured out, wait a minute, 4 is more than 3. Well, kind of. So, Atticus, do you know what we need to do here before we start? The hint kind of tells us, but when we have inches and feet in the problem given to us. Kind of, yeah, we got to do some kind of, I would highlight, underline, circle, or star, convert. Got to convert. Now, Carolyn, how do I convert from feet to inches?
You multiply 3 and 5 by 12.
So, to remind you of why we do this, 3 feet, I can really put over 1 because that doesn't change anything. I then multiply by 12 inches. This is our conversion factor. It tells me that 12 inches is equal to 1 foot. This is multiplication by 1 because these are the same thing, which is why I'm allowed to do that. This gives me 36 inches. This, when I multiply by the 12, gives me 60 inches. So now I have 36 inches and 60 inches. There's two ways, well, there's a lot of ways we could solve this, but there's 2 main ways. You want to keep going, Carol?
So next you want to find the area in inches of the whole entire thing. So you would multiply 36 by 60 and you get 2,160 inches.
So the floor is going to equal 2,160 inches squared.
And this one you don't tile the sheet.
Carolyn's problem.
And then you know that the tiles are each 4 by 4, which is 16.
Ah, so then the tile we notate is 16 inches squared.
You would just divide 2,160 by 16, which is 135.
Ah, so to solve our tiles, we want to do square inches divided by square inches. So we have the floor area divided by the tile area, which is going to tell us how many tiles it takes. You with me? Because I can tell you're not writing down. If you got this problem right, that's okay.
Yeah, I got it right.
I got it right.
Now, the question is, did you get it right because it was multiple choice and there were only 2 answers with tiles? Or did you get it right because you had work to support and you showed how you got there?
Me eliminate it.
Because if you don't have work to support this, it's not right. It was a guess. You have to have the work to support how you got your answer. Sebastian?
I was a little bit confused how you got the 12.
So that's kind of like known information. And on the state test, you have those conversion factors. They give those to you on the sheets. It'll tell you like feet in a yard, inches in a foot, all those things. So this is just our conversion factor that allows us to go from feet into inches, because it's just how many inches there are in a foot.
Okay, I was a
So-
bit confused.
Yeah, it's not from the problem. It's just kind of knowledge that we have.
Okay.
Brady?
I got that question right, and I had work to support it, but you didn't give me a check.
Maybe I just missed where it was. I mean, you come see me later if you want, but like I didn't put a grade on it yet, so you can give yourself a check if you want. Again, you guys are giving yourself your grades. You gotta either turn it back in, grade it as a mastery with support Y, like all the work shown and everything else, like your test needs to be done, or you're gonna grab a progression to mastery, do that, then turn it all back in together. And like that's only 8 questions. You could get it done in an extensions period. Yeah.
There didn't be a formula sheet on the second half, or
On the state test, yeah, like the OST or whatever.
we're doing that after the
So when we,
Yeah, you come back and you have a week to get back into the swing of things.
yeah.
And then they take a shot of it.
Well, and then we just take a couple more tests. Again, model it. Now, you have a bunch of different ways that you could do this. And a couple people drew this out in some interesting ways. The easiest, kind of most straightforward way to do this, chop it in half hamburger-wise, chop it in half hot dog-wise. We've now got 4 rooms in that multi-purpose space. Now, the other, well, another option, chop it in half long-wise, half again, half again. We've now got 4 really long rooms. That would not really work that well. That'd be difficult to teach in.
It'd be like you have to like stand right here, and then all your students are
Yep,
like in a
yep.
row right here.
You got to keep rolling. I'm running out of time. Another way, now this is how you go from like mastery to exemplary, is showing really creative ways. You can actually chop it this way if you want, and have triangle rooms. But if we go all the way back to our very simplistic green chopped, just cut into 4, we need to figure out what the length of the room will be now and what the width of the room will be now. How do I figure that out, Ella? Yeah. So this will be half of the 62, which is 31. This will be half of the 58,
Let me think.
29.
29.
Questions on how we got those lengths? So you're not chopping the values in by 4. I had some people that cut each of them in fourths because they figured, oh, we're making 4 classrooms. I divide by 4. No. If you divide by 4, you only divide one of them by 4, like when I drew those red long classrooms. We could divide one of them by 4 and leave the other one the same. But if I then go to find the area of one classroom, 29 times 31 comes out to be, you got it? I think it's like 899. It's got to have a label. Yep, feet squared. Any questions on this? Now, another way you could do it, like Carolyn was just saying, you could find the whole area of the whole thing and then just divide by 4. So that's another way that we could do it.
That's the cop out way.
Well, I mean, that's a fine method.
It's kind of
Volume. I start you off easy. You should have had a little bit of intro on this in 6th grade. If you didn't, it's not your fault. It's your teacher's fault. But you should have had a tiny intro. Well, we get kids from 12 different schools, right? So you guys all didn't have the same 6th grade teaching. Volume of prisms. Now, volume for any prism, we had the formula big B times H. But volume for a rectangular prism is just length times width times height. Which that's what I'm expecting you might have had a little bit of exposure to in 6th. So here, we've got 3 and 3 and 5. And when I multiply that all up, we get 45 units. Since it isn't given to us, we just write units. And you gotta have the right power. Now, some people, and this is fine, especially on my tests, wrote in here like inches, and then they gave their units as inches. That's totally fine. If you want to give it a unit, you can.
I give it comfort.
That is not a unit.
You know what's the funny thing? I actually did this probably in 5th grade.
Yeah?
Yeah.
Well, and it's pretty easy numbers to work with, which is why it's nice to kind of be one to just get you some exposure. It's going to the TV, man.
Okay. Yo.
Now, the tent problem here. Lots of people tried to use formulas and got all goofed up because of that. You do not need to use the formulas. That's a shortcut method. So if we wanted to find total surface area here, we'd have to use the formula where we have 2 bases and the lateral area, and we'd have to identify that this triangle is the base because it's a triangle to another triangle. So it's not the bottom, but it's the base, and that gets confusing for us. Let's not use the formula. Let's instead go back to our basic knowledge. Can I find the area of this triangle? Well, yeah, right? It's just a triangle. I've got the dimensions. What is our area formula? Actually, I'll call this F for front. We'll say this is the front of the tent. Zion, do you remember how to find the area of a triangle? How it compares to rectangle?
You would.
So if we had a rectangle, say we have a base length and a height, how would you find the area of that?
You multiply base times height.
Base times height. If I now make this into a triangle, how much space does that compare to what I had before?
You divide by 2.
Ah! So it's half of the base times the height, because triangles have to get cut in half. They're half of a rectangle. So this becomes half. My base and height have to be what with each other? Perpendicular. So this tells me my base and height are both 3, actually. Half of 3 times 3 is 4.5. Then move on. Could I, Leah, find this right face of my tent? What kind of shape is that to start with? It's a rectangle, right? So what's the length of the rectangle? How long is your tent? 4 meters. What's this edge of your tent that isn't labeled in the image? Yeah, you have to recognize there's some info in the problem setup that you need. You got to read carefully and identify, oh, that's probably important. I could not modify this picture. Like, I got the picture off the internet. But I could tell you some more information in the problem. So I couldn't modify the picture. I could not add in any text. So I had to tell you here. So then we compute that the area of the right face, yeah, 13.4, thank you for verifying. Then move on to anything else that's weird or anything that we haven't dealt with. Well, another really important part of my tent, especially if it rains, I've camped way too many times in the rain,
Oh, the rain cover.
is the floor. We've dealt with a front side of the tent and a right side of the tent, and we haven't done anything with the bottom. Well, what would be, Piper, our dimensions of the bottom? Yeah, 3 by 4. So my bottom here, and I might label BOT, is 3 times 4, or 12. Now, which of these faces have matching pairs? Like another face that is identical to it. Josh?
The front and back and the side.
So the front and back, if the front's 4.5, then the back is also 4.5. And I'll need both of these. So front equals, back equals. What else did you say?
The side.
So if the right was 13.4, then the left is 13.4.
Unless you said if you're 10.
well, unless your tent was made wrong, and then you still have your bottom. When you add all of those up, the total area that the tent uses for fabric, I believe it's 47.8. I think. That should be 9 plus 26. Yeah, 47.8. And then label that meters squared. Yeah.
We did we only used tarps and it flooded our campsite and we had to go down the side of a mountain at like midnight.
Oh my gosh, I've been there before though.
And then we couldn't sleep in our treehouse because there was lightning.
Yep, tree houses are a bit dangerous. I try to be a nice person. I really do. Not only as a teacher, but I mean in general. But I write my tests very intentionally. If you take the time to care about this problem, it sets you up for the next problem. You're ready to do volume in this problem in number 10 if you figured out the formula here in number 9. Caleb?
Wait, for number 10, or number 9, isn't
Good afternoon, Sean Renan and Riley Badillo. Please come to the office. Sean Renan and Riley Badillo to the office, please. Thank you.
I believe so. But yeah, sometimes people haven't cared enough about their homework that they forget about these problems by the time they come back around. So our normal formula for volume of a prism is big B times H, but that isn't an option. Well, what's that really mean? This is base area. This is distance between the bases. Well, to find the base area here, it's a triangular prism. So the triangle is my base. We've already talked area of triangle. This would be 1/2 little b, little h, using the little b and little h that they have right there. Then all we have to do is multiply by the distance between the bases. How long is my prism? What's the distance between them? What's that labeled as here? Yeah?
L.
Yeah, the cursive L. So I end up with this. This little section is your big B, and that L is your height. So then when we come to our next problem, we're ready. All we got to do is half the little b, little h times the height. But we have one little problem. Who can tell me what the problem with this problem is? Hardy Hart. Carolyn? I only got 3 people apparently.
30.
Well, okay, that,
Oh, I
but
know. They're not all the same units and inches in their feet, so you have to convert it.
they're not all the same units. So Sebastian, I'm doing this intentionally, and your card came up. What's my conversion factor to go from feet to inches?
Oh, say 12 inches divided by 1 foot.
Yeah, that 12 that we used earlier. So we multiply. If you want to use the whole conversion factor, it's 12 inches over 1 foot, because then my feet units cancel out. This becomes 24 inches. You'll do half times the 10 times the 8 times the 24, and you should get a volume of 960.
Yeah, 960.
There's an easier way to write it that takes up less space.
Wait, 1/2 times what? Times the 8 times the 10 times 12.
So we use this formula from the last one, where it's half little b, little h, times the distance between them, which here becomes half times 10, 8, and 24.
Doesn't matter what order.
Not really, because multiplication is commutative. Order is irrelevant. Rubik's Cube problem on the next one. If you've done much with Rubik's Cubes, it would make sense. Or just think about if you actually were going to paint this, and I paint the whole thing. Well, this right here is your indicator. Ellie?
So, all if one cube is six-sided, like it's little squares. So, the ones that are the corners would have three painted sides if you're painting both sides, because there's one side of the cube on each face, one side of the square on each face. Yeah.
Now the issue when people start talking about corners, do not overcount. These three faces are all one corner, so that's one cube. 2, 3, 4, 5, 6, 7, and there's one more back there that we can't see. There are 8 corners on that cube that would all be painted. I'll see if we can modify some plans to cover some more of these questions. So I have a feeling that people would like to see these other questions, but we're behind. Like, kind of like what Mrs. Collin was saying. So thank you guys. We will talk more about this tomorrow, but grab a Progressing to Mastery if you need it, which most of us probably do.